So in this video, I'm going to cover fractions, one of the more important topics in both P5 and P6. So without further ado, let's begin. So here we have 27 over 36 to be expressed in the simplest form. Well, the first thing I hope you can see is that they are both multiples of 9. So let's divide by 9 for the numerator and the denominator, so you get a 3 over 4. Next, we have 16 over 56 to be simplified to the simplest form. So it helps to know your multiplication table very well. So if you divide by 8 on both sides, you will get a 2 and a 7. So 2 over 7. Next, we have 16 over 3 in the simplest form. Well, if you notice, this is larger than this number. So when the numerator is larger than the denominator, we call this an improper fraction. So what we can do is two things. My preferred method is to split 16 into 15 and 1. Now, why do that? Because 15 is very easily divided by 3. That gives us 5 wholes. So what do we do with this remainder 1 here? Write it as 1 over 3. Look at this part here. Well, the more common method is just to use long division, 16. Now remember, this fraction bar here actually represents division. So 16 divided by 3 gives us 5 minus 15, remainder 1. You will arrive at the same answer for both cases. Next question. So we have an improper fraction again. So we can either do this, which is 13, split it up into 7 and 6. Why? Because when we divide by 7, this is 1 whole. This is remainder 6 over 7. Alternatively, long division can be used and you should arrive at the same answer. Next, an improper fraction in the simplest form. Looking at this, we can again use this method. So think of the largest multiple of 9 that you can obtain from 47. It is 45. So 45 divided by 9, that's awesome. That's 5 wholes. The remainder here is 2 over 9. Okay, long division can also be used. So here we have 5 and 3 over 8 to be expressed as an improper fraction. So if this denominator is 8, then we were going to take 8 times 5. Why? Because 1 whole here is 8 over 8 units. 5 wholes will therefore be 5 times 8 plus that remainder of 3. So we know that 5 times 8 gives us 40. So 40 plus 3 gives us 43. Next, we have this to be expressed as an improper fraction. So 1 whole is 8 over 8. 6 wholes, therefore, is 6 times 8 units. So that's 48 units plus 7, giving us 55 over 8. Now we have an improper fraction to be expressed as a mixed number. So either we find the largest multiple of 6 that we can find, which is 24. Okay, and then 24 divided by 6 gives us a nice 4 wholes. And look at this, this is 3 over 6, which can be expressed as 1 over 2. Or use the good old long division and you get the same answer. Okay, right now we have this to be expressed as a mixed number. So method 1 is to basically split it up into multiples of 4. For example, 51 is made up of 40 and then an 11, right? But I don't want to write 11. 40, 8, and 3. Why? Because this is 10 and a 2. So that's 12. Remainder 3 over 4. So the more you do this, the faster you get, the more you can skip long division, which you can do, it's just slower. Alright, so now we have this 2 wholes and 3 over 5 to be converted to this, which basically makes us convert to the improper fraction. So what we can do here is to understand that we have 2 wholes, okay, and then we take 2 times 5, that's 10, plus 3, that's 13. So our answer is not 13 over 5, however, the answer is what's in the box, 13. Well, we have an equal sign here, but this 10 is not equal to the 35, is it? Okay, so some manipulation is required here. So I'll start off with 10 over 18. Now I'm going to divide by 2 both sides. Why? Because then it gives us 5 over 9. So why is 5 over 9 useful? Because if you times 7 on both sides, for both, you will obtain 35. Okay, so having obtained 35 for the numerator, look at what's below. That's our answer, 63. Right, so here we have a situation where our denominator here is 8, but our denominator here is 16. Well, let's manipulate this. So 38 over 16 can be written as 2 wholes and 6 over 16. So you can use long division to obtain this, but our denominator is not 8, is it? our denominator is currently 16. So divide by 2, you get 3 over 8. So the missing number in the box is therefore 3. Okay, so 9 over 24, well, again, equal sign, but our 9 is not equal to 12. So let's turn 9 into 12 somehow. Okay, we're going to divide by 3 first. So 9 divided by 3 is 3, 24 divided by 3 is 8. Can 3 turn into 12? Absolutely. Just times 4 on both sides. You get 12 over 32. So the missing number is 32. Which of the following is equal to this fraction right here? So notice there's no, well, straight away you can tell all of them are improper, so they're not making it too obvious for us. Next, let's take a look. Everything, just convert every one of them one by one to improper fractions. And you will find out that it is actually 23 over 6. That is the answer. Express this as a mixed number. Well, both are even numbers. That's one thing we can tell straight away. Or you can just divide by 4 and get 5 over 2. And then 2.5. Alternatively, you can use long division. You can count on it all the time, just a bit slower. Next, which of the following is equivalent to 6 over 15? Okay, well, the first thing I can tell is that 6 over 15 by itself is not even the simplest form. Let's divide by 3 on both sides, getting us 2 over 5. And hey, it's our lucky day. 2 over 5 is right there. So the answer is number 3. They are equivalent. Next, 38 over 7 as a mixed number. Well, we are going to use long division to obtain the answer. And that's it. 5 wholes, remainder 3. 58 over 4 as a mixed number. So we can divide it by 2 first to make our lives easier to get 29 over 2. Then from here, 29. What's a nice big fat multiple of 2 that we can obtain? 28. Now what's cool about this? 28 divided by 2 is 14 wholes. 1 over 2 is the remainder. That's it. Also, use long division. You can obtain the answer as well. 11 over 3 as a mixed number. So what we can do is to extract 9. So turn 11 into 9 plus 2. So that 9 divided by 3 gets us 3 wholes. Remainder 2 gets us 2 over 3. Now on to level 2 questions. Okay, well, first thing you notice here is the denominators are not the same. Plus we have an improper fraction expressed with 4 wholes here. So what can we do with this? First thing I do is to divide by 2. I'm trying to obtain denominator 6 over here. So I'm going to divide by 2, I get 27 over 6. Well, from here, I can see that I can obtain 4 wholes, leaving behind remainder 3. So make sure your denominator is the same here. And in this case, it's 6. So what's the numerator here? It's number 3. Okay, so first thing I do is to try and make the denominator 10. So what I can do is to times 2 for top and bottom, giving me 72 over 10. Express this improper fraction as a mixed number, and hey, it's a lucky day. Denominator 10, 7 wholes, numerator 2, and therefore 2 is the missing number. Okie dokie, so here we are trying to see if we can obtain 9 as the whole number, and I think we can. So right here we can straight away get this to 9 and 2 over 9 using long division. And what do we have? Is 2 the answer? Or sorry, is 9 the answer? No, because I've got 10 as the numerator here, whereas currently I have 2 as the numerator here. So let's turn this into 10 multiplied by 5. So we get 10 over 45. So the missing number is actually 45. 66 over 13. Well, first let's turn this into a mixed number, 5 and 1 over 13. Can we use 13? Nope. Why? Because the numerator is currently 1, but we want the numerator to be 3. So let's times 3 top and bottom. We get 3 over 39, and voila, our answer is 39. 6 over 9. Okay, well, you can tell that these two are multiples of 3. So let's divide by 3, obtaining 2 over 3. And let's turn the denominator into 12. So we times 4 on top and bottom, and we get 8 over 12. So the missing number is therefore 8. We have something over 9 equals 8 over 12. Okay, what we can do is try and manipulate 8 over 12. So let's divide by 4, getting us 2 over 3. Why is 2 over 3 useful? Because from a denominator 3, we can turn it into 9. So multiply by 3, getting us 6 over 9. So the answer is 6. Right, so from here, we should focus somehow on going from 9 to 15. So how do we do that? We divide by 3 first, getting us 3 over 8. And what do you see? 3 can be turned into 15 by multiplying by 5. So do it for the bottom as well. The answer here is 40. Well, we have to turn denominator from 9 to 27. So what we can do is to first turn this into an improper fraction and then multiply by 3 so that it becomes 27 for the denominator. And the answer here is 42. Well, the denominators here are both 3, but the whole number is different. Okay, so what do? Let's turn the whole number from 4 to 3. Let's do that. So notice that what is the meaning of 4 wholes and 2/3? That means I've got 4 groups of 3 and a remainder of 2. Well, let's say we already have 3 holes, right? Let's keep 3 holes here. 3 holes here, 1 hole, 2 holes, 3 holes. Now what's left behind? 1 hole, 2 holes, 3 holes. What's left behind? Is it remainder of 2? No, it's a remainder of 5. So using this example here, you can tell that the answer is 5. Another similar question, regrouping here. So the denominators here are the same, 5 and 5, except the whole numbers that are different. So let's have this situation here. We start out with 5 holes, 2/5. What does that mean? 1 hole, 2, 3, 4, 5 holes, and a remainder of 2. Okay, so now we are asking ourselves, okay, we've got 3 holes here. So 1 hole, 2 holes, 3 holes. What's left behind from here? It's actually 10 plus 2, isn't it? So it's actually 12 holes remaining. Okay, we're interested in turning the numerators from making them the same. So from 4, turn it to 16. Well, we're going to multiply by 4. So yes, now we've got numerator 16 and the denominator is 24. The answer therefore is 24. Next, we're going to turn 16 to 20 and observe what the numerator is. So what we can do is to divide by 4 on both sides, turning this into 3/4. And from denominator of 4, we can turn it into 20 fairly easily, multiply by 5, and the answer is 15. Now, 4/7 is not the same as which? Okay, hang on. If you understand 4/7, what does that mean? 4/7 basically is 1/7, 1/7, 1/7, 1/7, 4 times, right? So that's 4 1/7. So this is actually the same. But we want an answer that's not the same. Okay, actually, the first one is not the same. Well, what is 1/4 times 7? It actually turns out to be 7/4. So this is obviously wrong, and it happens to be your first choice, so you can obtain your answer straight away. Well, to confirm, you can just calculate and make sure that the other 3 choices are the same, but not necessary. Right, so somehow we're going to turn the denominator from 42 to 48. Okay, so let's do that. We'll divide by 7 for the numerator and the denominator, getting us 2/6. And 6 can be turned into 48 quite easily, just multiply by 8. So our numerator here is 16, therefore the answer is 16. The denominators are the same here, but the whole numbers are different. So what we can do is to say, either you can draw the marbles that I did earlier in a few questions ago, or you can do this. See these 4 holes here? Well, separate 2 holes out. Take out 2 holes. Because why? We are trying to show that, okay, we have the 2 holes accounted for here, right? There it is. But what's left behind here is actually 2 and 1/6, which is 13/6. Therefore, the answer is 13. See, the 2 holes accounted for right here. What's left behind is 13/6. So our answer is 13. Okay, so this is how you do it numerically without having to draw all the marbles. Let's employ the same method as before. So here we are going to say, all right, you got 5 holes, right? Okay, let's take 3 holes out to account for this number here. What are you going to be left behind with? You're going to be left behind with 2 holes because you started out with 5 holes. So the 2 holes times 4 gives us 8 plus 3. That's 11/4. Therefore, the missing number is 11. Okay, so 8 holes. Let's take out that 5 holes, leaving behind 3 holes and 1/4. So turn this into an improper fraction. So that will be 13/4. So the missing number is 13. So we have to turn 9 to 12 over here. We start out with 6/9. We're going to divide by 3, top and bottom. So it gets us 2/3. So we're going to times 4 throughout again to obtain 8/12. Therefore, the answer is 8. So we'll start off with this, turn this into 25. Okay, so divide by 3, we get 4 over 5. Times 5, we get 20 over 25. So the answer is 20. So with 6 over 18, we're going to divide by 3, top and bottom. We get 2 over 6. And now with a denominator of 6, we're going to get to 12. So we'll times 2. Times 2 gets us 4 as the answer. Ooh, now this is slightly more challenging. Well, we know for sure we have an improper fraction for the answer. Not just that, our denominator has to be 10 now instead of 5. Okay, so I'm going to turn the denominator, well, turn it into an improper first, which is 8 over 5, and then multiply by 2 throughout to get 16 over 10. Therefore, the missing number is 16. Okay, so same thing here. You notice this is a mixed number. Turn it into an improper fraction, and then make sure the denominator is 18. Well, let's do that. Improper first, so 13 over 9 times 2 top and bottom, and then here we have 26 over 18. The answer is 26. Okay, so let's extract 2 wholes from here, or what did I do here? So I times 2, 3 and 6 over 8. Extract 2 wholes out from that 3 wholes. So you're left with 1 whole and 6 over 8. And then turn this into an improper fraction. So this is now 2 wholes and 14 over 8. 14 over 8. So the answer is 14, which is not equivalent to 14 over 4. Okay, the first thing I would do is to say 28 over 16. Yep, if you divide by 4 throughout, you get 7 over 4, simplified, right? So the denominator is 4, that's right. But the numerator is not 14 though, so this is definitely not what we're looking for. Yeah, and because that's the first choice, that's the answer. Next, we're going to turn 24 to 32. We're going to divide by 3. So that gets us 8 over 9. And from here, times 4 times 4, you're going to get 32 over 36. The denominator here is 36. That's the answer. Okay, look at this. What's accounted for over here? This is 12 holes. We've got 10 holes accounted for, 2 holes accounted for. That's nice. So look at this part here then. This is 30 over 100. And we've got 32 though. Well, if you know your fractions, okay, you should know that this is 32 over 100. The 12 here is accounted for. So what's 32 over 100 minus 30 over 100? Well, that's pretty easy because the denominators are the same. We can carry out the subtraction quite easily. So that's 32 minus 30, that's 2 over 100. We do not simplify this to the simplest form. The answer therefore is 2 over 100. The question mark represents 100. 78 over 9. Well, they're looking for, this is an improper, so let's turn this into a mixed number first. Okay, so we turn this into 8 and 6 over 9. Well, that's okay, but we've got 7 holes only. So let's separate that 7 holes out. So we're left with 1 and 6 over 9. Okay, then turn this into an improper fraction and make sure that the denominator is 3. So what can happen next is work with this. Turn this into an improper fraction and then divide by 3, giving us 5 over 3. So 7 holes accounted for, denominator 3 accounted for, numerator is 5, the answer is 5. Okay, somehow we have to carry out this addition and make sure the numerator is 33. Yeah, so let's add them up together. So make sure the denominators are the same before you carry out the addition, giving us 11 over 15. Now make sure the numerator is 33. So we're going to times 3 times 3, giving us 33 over 45. Well, the question mark here represents 45, and that's the answer. So we have to turn this into 3 for whole number and 9 for the denominator. So let's start with 4 and 2/3. Let's turn the denominator to 9 first, giving us 4 and 6 over 9. Now take out that 3 holes. What are you left with? 1 hole. So 1 hole means 9 plus 6. That's 15 over 9. Therefore, the missing number is 15. So we'll turn 24 to 32. We'll divide by 3, top and bottom, giving us 8 over 9. Then we'll times 4, top and bottom, 32 over 36. So the answer here is 36. Ooh, okay. Well, this is pretty easy to figure out. What happened here? We're just multiplying by 2 top and bottom, yeah? Okay. So the question is, can we turn somehow this 7 over 14 into a fraction with 18 as the denominator? Well, let's do it. Okay, so we'll divide by 7, giving us 1/2. Can 1/2 turn into, can this 2 here turn into 18? Absolutely. We'll just times 9. And the answer is 9 over 18. No, sorry, the answer is 9. And now a level 3 question. Okay, what do we have here? So we've got 3 over 5. Somehow this is expressed as 3 plus 6, which is 9, isn't it? Well, can we turn this numerator 3 to 9? We absolutely can. So we're going to times 3 times 3. That gets us 9 over a 5 plus what? Okay, so if we times 3, is it not a 15? Right, that's a 15, isn't it? And that's a 5 plus 10, is it not? So when we multiply by 3, top and bottom, we get 9 over 15. So that this 9 here accounts for the 3 plus 6. And this 15 here is actually 5 plus 10. So 10 is the missing number. So right here we have a 5. This here is a 15. So first thing we do is to times 3 top and bottom. We get us 15 over 18. Well. So 15 accounted for 5 plus 10. 18 is 6 plus what? So the answer is 18 minus 6. The answer is 12. 8 over 15. Well, this here is 24. So we're going to times 3, top and bottom, giving us 24 here. And the bottom here is actually 45, is it not? This should be a 45. Okay, so what we have here is 45 minus 10, giving us 35. Now, what's given to us here? Whoa, okay, so this is 1 whole and 4 over 9. Whereas this is, well, we can add this up and figure out what that is. That's basically 45. Can 9 turn into 45? Absolutely. So what we will do is first convert this to an improper fraction, then multiply by 5. Okay, so that it means this is a 65 over 45. And this is given to us as 45 right now. So 65 is equal to 15 plus what? Well, 65 minus 15 is 50. Okay, what do we have here? This is basically 28, is it not? So we have to turn this somehow to denominator 28. And not just that, the 3 wholes is gone. There's no whole number here. So we will first turn this into an improper fraction, which is 51 over 14. Now we want the denominator to match 28. So times 2 times 2, that's 102 over 28. Well, 3 times what gives us 102? Well, we will take 102 divided by 3, and that gives us 34. And yeah, congrats, that's the end of this whole exercise. Hope you found this productive. See ya!